In this problem, we have Beardy and Not So Beardy pushing off each other. It's two hipsters, and they're in rolly chair, and the one with the beard has less mass than the guy without the beard. So the one with the beard is going to push on the other guy. Which one feels the greater force? Well, even though this guy's doing the pushing, the Beardy is doing the pushing, he actually will feel the exact same force as the other guy. Why is that? Because for every force, there is an equal and opposite force. So they have the same force. Who has the greater acceleration? Well, if they're both feeling the same force, and this one guy over here feels a smaller mass, and this guy has a bigger mass, he's got to have a bigger acceleration to make up for that small mass. This guy's going to have a smaller acceleration. So Beardy would have the greater acceleration. And which hipster will experience the greatest change in momentum? Well, we just talked about forces. Same thing is true with momentum. They're both originally at 0, and they're going to be moving afterwards. So this is a explosion problem. They start with 0, and this guy has some sort of positive momentum this way, and this guy has some negative momentum this way. They still have to add up to 0 afterwards. So this momentum has to be equal to this momentum. So their change momentum will be the same. So this guy's change in momentum is equal to this guy's change in momentum. Now, which will have the greater velocity after they fly apart? Well, they're going to have the same final momentum because they're flying. They started at rest and they're flying apart with the same change in momentum. Beardy has a smaller mass. Not Beardy has a larger mass. So since momentum is mass times velocity, that means this guy's going to have the larger velocity to make up for the small mass. This guy's going to have the smaller velocity to make up for the large mass. So the Beardy guy would be moving with a greater velocity.